So let us start with today's class. Okay, it is audible, no?
Yes, ma'am.
Okay, so let us start with the class. So last class we have completed few questions on current electricity last to last week. Last week it was a holiday because of Independence Day. Okay. Yes, I think so. We need to start from this question. See, here it is based on the Wheatstone network. In Wheatstone's network, P is equal to 2 ohm, Q is equal to 2 ohm, R is equal to 2 ohm, S is equal to 3 ohm. The resistance with which S is to be shunted in order that the bridge may be balanced. So here, what they're asking here, you need to imagine the Wheatstone network. So if you see the Wheatstone network here, you can take the network. You can take it as R1, R2, R3, R4, or you can take it as PQRS also. So anyhow, however you have learned in your college, you can take that. So now we are going to take so here we can take it as P, and here it is Q, here it is R, and here it is yes. Okay, so here P is equal to, they have given it as 2 ohm, Q is equal to also it is given as 2 ohm, and R is equal to it is given as 2 ohm, and S is equal to it is 3 ohm. The resistance with which S is to be shunted in order that the bridge may be balanced. So here if you see P, Q, R, S, all are 2 ohm, but S is what? 3 ohm. So when you can say that the Wheatstone network is balanced, when it is P by Q is equal to R divided by S. So when this is equal, we can say that the bridge is balanced. So what they're asking in the question, ಎಷ್ಟು resistance ನೀವು ಇಲ್ಲಿ ಎಸ್ ಸಿ ಕನೆಕ್ಟ್ ಮಾಡಬೇಕಾಗತ್ತೆ so that bridge becomes balanced, because ಇಲ್ಲಿ 3 ohm ಇದೆ. So which resistance you can connect here to make the bridge balanced? I hope so the question is clear to everyone. If not, you can tell me in the chat box to repeat. Yes, so we need to calculate the value of X resistance, which is shunted means which is going to connect at yes. So that is connected at yes, so that this becomes balanced. The circuit becomes balanced. Okay, so now see here how to do this. We are using the same concept. Here X is our some unknown resistance which is connected at yes, which is to be balanced. So according to Wheatstone network, the condition is what? P by Q is equal to R divided by S. So now this I'll write it as P by Q is equal to R divided by. So for yes, we are connecting a resistance. You can see they are looking like they are in the parallel combination. So ನೀವು ಅದನ್ನ ನೋಡಿದಾಗ ಅದು ನಿಮ್ಗೆ ಯಾವ ತರ ಕಾಣಿಸ್ತಾ ಇದೆ? Here you can see this combination is in parallel combination, right? S and X are in parallel combination. So for parallel combination, even though this concept is deleted, that is parallel resistance, here there is a use of that one. So therefore, for the parallel combination, the effective resistance is R1 into R2 divided by R1 plus R2. This is effective resistance when it is in the parallel combination. So therefore here one is S resistance, R1 andre S agate, R2 andre X agate, divided by here R1 plus R2. So that is S plus X. Now we can substitute all other values, because we know P value, we know Q value, we know R value, we know S value. Yes, so for that we can substitute, and let us calculate what is the value of X. So see, P value is 2 upon Q value is also 2, which is equal to, so the R value is 2 divided by, this is S value is 3, X you keep it as it is, and this divided by, that is 3 plus X. We need to calculate the value of X, students. Can anyone tell me what is the answer? So here 2 by 2 will be 1, which is equal to 2 into bracket 3 plus X upon 3x. So what is the value of x? Yes, other students. One student gave the answer. Yes, correct. 6 ohm. Yes, Rx is equal to 6 ohm. Yes, question is clear to everyone. Anybody want me to explain once again? You can tell. ಎಲ್ರಿಗೂ ಅರ್ಥ ಆಯ್ತಾ? So your x value is, if you simplify this, x is equal to, so ಇದೇನಾಗುತ್ತೆ 3x ಅನ್ನ cross multiply ಮಾಡ್ಕೊಳ್ಳಿ. Here it is 2 into 3, 2 3s are plus 2x. So 3x minus 2x is, it is x is equal to, it is nothing but 6 ohm. So therefore answer is option B. Option B is the correct answer, that is 6 ohm. Okay, so if you connect 6 ohm at yes, your circuit becomes balanced. Your circuit becomes balanced. So that is B option is the correct option. Okay, hope so everyone copied this. Going for the next question, students. If it is not clear, please ask. Okay, so here is your next question. So in the following network, at the potential network, the potential at O is. So see the figure, how it is there. So in the following figure, the potential at O is. So here, this is A point, and here we have O point, and from here we have two branches. You can take the circuit. Okay, so this is B. This point is B, and here one more branch is there, and this is C. So here we have 2 ohm, and here we have 4 ohm, and here there is a 2 ohm again, and at A we have 8 volt, and at B we have 4 volt, and at C we have 2 volt. So please copy down the circuit. Yes, Lubna, your answer is right. Yes, see here, students, what you need to calculate in the following network, the potential at VO is, the potential at O is. Yes, so at this point, we need to calculate the potential. So for this, so many different methods are there. So here I am going to adopt one simple method. So whenever you have this type of circuit, use the same method to solve this. Here, what happens? The current IA is equal to the current entering in, that is current entering through A is equal to, it is the current across B and the current across the C. So here whatever IA is there, that is the sum of your IB and IC. Your IA is equal to IB plus IC. Okay, so for this we can write it as, yes, Shiruni, answer is right. Okay, according to Ohm's law, the current I is equal to, it is V divided by R. So here we can take it as your IA is, it is VA upon R. But here what happens? We have terminal. One is A terminal and one is O terminal. So therefore this becomes VA minus V naught upon RA is equal to V naught minus, it is V naught minus VB upon RB plus V naught minus VC upon RC. So here we use, that is I is equal to V divided by R, but we have network. Therefore here this is the VA potential and this is V naught potential, and this becomes VB potential. Here it is, here VB potential, and here it is V potential. So we can write it as the net potential at that point. So now we can substitute the values. So VA is given in the figure, it is 8 volt minus V naught. Keep it as it is upon RA The resistance is given, it is 2 ohm, which is equal to, here it is V naught dB is 4 ohm upon, the resistance is 4 ohm plus, here it is V naught minus C. VC is 2 volt upon the resistance is 2. You can simplify it for V naught, students. You can simplify it for V naught. So what we can do here, we can take the LCM and we can cancel. Okay, just a minute. I think you're not able to see the PPT. Yes. So some students have got the answer. Okay, so we got 8 minus V naught upon 2, which is equal to V naught minus 4 upon 4 plus V naught minus 2 upon 2. So here on this side, the LCM will be 4. So 4 means here it will be V naught minus 4 plus 2 into bracket, this one. So it is 2 V naught minus 2 2s are 4. And here it will be 4. And here this side it is 8 minus V naught upon 2. So this we can cancel it as 2 1s are 2 2s are. Now we can cross multiply this 2 on the other side. 8 2s are 16 minus 2 V naught is equal to V naught plus 2 V naught is 3 V naught. 4 minus 4 minus 4. Plus into minus minus, yes. This will be minus 8. So if you simplify for V naught, your V naught will be 4.8 volt. Option D baratte check madi. Yes, everybody got the answer. So 16 plus 8, it will be 16 plus 8 will be 24. 24 upon 5. It will be 4.8. Check. Correct or no? Everybody got the answer? Yes, Akila. Okay. Any doubt is there? Remaining students, shall we go for next question? Okay, see the next question. Question number 13. The quantity of charge that will be transferred by a current flow of 20 ampere over 1 hour 30-minute period is. So here what you need to calculate? You need to calculate the quantity of the charge that will be transferred by a current flow of, so the current flow is given, it is 20 ampere and the time is given as 1 hour 30 minute. Okay, so what you need to calculate? The quantity of the charge you need to calculate. So what you will do, you use the basic definition here, students, that is I is equal to dq by dt or q by t. So we require q, therefore it is I into t. So I is given, but time is given in hour and minute. Convert it into seconds. Please tell me how much it will be in seconds. 1 hour 30 minute ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. So 1 hour 30 minute seconds ಅಲ್ಲಿ ಎಷ್ಟಾಗತ್ತೆ? Yes, 1 hour 30 minute will be how much? 1 hour 30 minutes. In seconds, you have to convert. We cannot take it in the hour and minute. Yes. Correct, Shivaruni. 180 extra you have written or what?
5,400 seconds.
Yes, 5,400 seconds. So you can just multiply and check with the answer, students. 13, question number 13. So 20 into 5,400 seconds. Yes. Yes, Lubna, your answer is right. Yes, JNV students, hope so you are getting the answer. So this will be 5,400 seconds. So you just need to multiply 54 into 2 and the remaining zeros. Yes, option B. See here. ಎಲ್ರಿಗೂ ಬರುತ್ತೆ ಆಪ್ಷನ್ ಬಿ ಬರುತ್ತೆ ನೋಡಿ 10.8 into 10 to the power of 4. Option B is the answer. 10.8 into 10 to the power of 4. Option B. Yes, I'll give you 1 minute. Go for question number 14. A cylindrical conductor of diameter 0.1 millimeter carries a current of 90 milliampere. The current density is, so 13 copy ಮಾಡ್ಕೊಳ್ಳಿ, 14 try it. I'll give you 1 minute. Yes, answer A for 14. Yes, A is the answer. So see here, students. So 13B baratte, 14th one, just check. Okay, so 14th, they are asking you to calculate the current density. So the current density is denoted by the letter J. The current density is given by current per unit area. So current is given, it is given as how much? 90 milliampere. It is 90 into 10 raised to minus 3. But area is not given, but cylindrical conductor they are saying. So cylindrical conductor, so if you want the cross-sectional area, the cross-sectional area of that conductor is given by the cross-sectional area of that conductor is given by pi d square upon 4. It is pi d square upon 4. Okay. So now we can take that pi d square upon 4. So if I write pi d square upon 4, the 4 will go in the numerator. The pi value is 3.142 into the diameter is 0.1 into 10 raised to minus 3 because it is in the millimeter. So the 10 raised to minus 3 will get cancelled. Remaining values you simplify, you will get option A. Option A baratte nodi. Option A is the correct answer. Okay, going for the next question, students. The effective resistance between P and Q for the following network is. So again, we need to take a circuit diagram here. So the circuit diagram is given like this. What is the value of the effective resistance they are asking? So here we have the P and here we have this is R, P, R, Q. And here we have one more resistor. This is 6 ohm. This is 3 ohm. This is also 3 ohm. And here this is 4 ohm. And here it is 5 ohm. So you can see the value of the resistance which is given for the following circuit diagram. They are asking you to calculate the effective resistance between P and Q. Yes. So if you simplify the circuit here, so here we have the 4 ohm. Okay. Here if you see the 3 ohm and the 3 ohm, whatever 3 ohm you are seeing here value, these two are in series. 3 ohm, 3 ohm. So you can see that ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ ಈ ರೀತಿಯಾಗಿದೆ. So ಈ 3 ohm, if you stretch this wire, this 3 ohm, both are in series. Both are in series. 4 ohm series ಅಂತ ಹೇಳಿಕ್ ಬರಲ್ಲ because here you can see here one more connection is there, right? So therefore 3 ohm are in series combination. So series combination only the effective resistance will be R1 plus R2 which is equal to 3 plus 3 is 6 ohm. So therefore now this 6 ohm is in parallel combination with one more 6 ohm. This is also 6 ohm and this is also 6 ohm. And here we have the 5 ohm. So one second, I'll draw this once again. So here we have the 4 ohm. Here there is a 6 ohm. Here 4. This is 5. Okay. So now here whatever this 6 and 6 is there, this is in parallel combination. So for the parallel combination, here it is 1 upon Rp is equal to 1 upon R1 plus 1 upon R2. So that will be 1 upon 6 by 1 upon 6. The answer will be 3 ohm. Okay. So now the effective resistance will be what? This is the 4 ohm. This is 3 ohm. And here it is 5 ohm. Now you can apply all series combinations. So 4 plus 3 plus 5 is equal to 12 ohm. Option C is the answer. Option C. So many students have got the answer. Option C. You can copy down. We will go for the next question. Yes, completed. Any doubt, students, up to this question?
No, ma'am.
Okay, so the next question. See the next question. A copper wire of length 1 meter and uniform cross-sectional area 5 into 10 to minus 7 meters square carries a current of 1 ampere. Assuming that there are 8 into 10 to 28 free electrons per meter cube in copper, how long will an electron take to drift from one end of the wire to the other? So how long will the electron take to drift from one end to the other? So how long means what? You need to calculate the time here. Okay. So what all it is given, see, that is the length value is given. The length is given as, it is 1 meter. Length is given as 1 meter. And the cross sectional area is given as 5 into 10 raised to minus 7 per meter square. Carries a current of, so the current value is given as 1 ampere. Assuming that there are 8 into 10 raised to 28 free electrons per meter cube. That is, n value is given as 8 into 10 to the power of 28. So we need to calculate time. So what we can do here, we know that is velocity is equal to distance upon time. But here we need to consider the drift velocity. Therefore, I can write it as drift velocity is equal to distance upon time. So this distance is nothing but the length of the cross-sectional wire upon time. So length value is given. So time we need to calculate. Therefore, time is equal to ಏನಾಗುತ್ತೆ? Length upon drift velocity. But the drift velocity value is not given. So, but we know that from current and drift velocity relation, I is equal to NEA VD. Therefore, VD is equal to, it is I divided by NEA. VD is equal to I upon NEA. So therefore, this is equal to L divided by VD. So VD is I upon ಇದೆ. So numerator ತಗೊಳ್ಬಹುದು NEA. So you can do the further calculation. Yes. So time is equal to length is 1 meter into 8 into 10 raised to 28 10 to the power of 28 into charge of electron is 1.6 into 10 raised to minus 19 into area. It is 5 into 10 raised to minus 7 upon the current value. So what is the value of the current? The current value is 1 ampere. So simplify the answer and check what you will get. Yes, option D. Remaining students, yes, option D ಬರುತ್ತೆ ನೋಡಿ. So 6400 seconds you will get. Therefore, it becomes 6.4 into 10 to the power of 23. Yes, option D. So go for question number 17, students. So see, in an atom, electron revolve around the nucleus along a path of radius. Actually, this question we have completed, first question of the class. So here, the revolution per second means it is given as frequency. So this we have completed already, if you remember. This is repeated, leave it. Let us go for the next question. Yes, see the next question. With increase in temperature, the conductivity of metal with increase in the temperature, the conductivity of the metal is metal increases, semiconductor decreases, metal decreases, in both increases, in both decreases. Yes, remaining students, what is the answer? With increase in temperature, resistance, metals conductivity, reciprocal of resistivity. Yes, how you define conductivity? Conductivity is nothing but reciprocal of resistivity. So resistivity is nothing but it is a resistance. So here what happens? That is the conductivity is equal to the reciprocal of resistivity. So this is nothing but resistance. We can just assume it because here resistivity is defined as resistance per unit length per unit area of cross section. Okay. So conductivity ಏನಾಗುತ್ತೆ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. See here, option A is the answer. In case of metals, it increases, and in case of semiconductor, it decreases. So if you remember, so semiconductors, how you increase the temperature, resistance ಹೆಚ್ಚಾಗುತ್ತೆ. So when you increase the temperature, it increases, therefore the conductivity decreases. So option A is the correct answer. Okay, option A. While the semiconductor decreases. So question number 19, C. Hope so everybody is solving. Only if you see the questions, you will not get the answer. Okay, now you check. Yes. So the next question, students, 10 identical cells of each potential E and internal resistance R are connected in series to form a closed circuit. An ideal voltmeter is connected across 3 cells will read. So they are asking you what is the voltmeter reading. In short, it is a potential you need to understand for the cell combination. 10 identical cells, each of potential E and R is the internal resistance which is connected in series, which is forming a closed circuit. What is the voltmeter reading? Previous one second. I'll complete this and I'll check with the previous one. Yes. This is how to do it, students. Previous question, A option is right, no? Because see here, okay, if you imagine only semiconductor, so semiconductors ಅಲ್ಲಿ ಏನಾಗತ್ತೆ ಅಂತ ಅಂದ್ರೆ when you increase the temperature, so here when you increase the temperature, whatever that arrangement of the atoms are there here, means if you, I think semiconductors it is completed in college, but here we have completed that. So semiconductors examples will be a tetravalent, right? So tetravalent ಅಲ್ಲಿ ಏನಾಗತ್ತೆ, we will have 4 valence electrons. Okay, so when we increase the temperature of this, when we increase the temperature of this, here the arrangement will change. Either the one atom will go out, here it will get empty, so that is called as the hole here. So when the hole will get by the temperature, ಅವಾಗ ಏನಾಗತ್ತೆ ಅಂತಂದ್ರೆ ಸೆಮಿಕಂಡಕ್ಟರ್ದು ರೆಸಿಸ್ಟೆನ್ಸ್ ಆಗುತ್ತೆ. For semiconductor resistance, 1 minute. Okay, so for the previous question, that is question number 18, just I want to correct that. Here what happens, that is when you increase the temperature, the electrons will go in case of this one, what is that, semiconductors. So ಅಲ್ಲಿ conduction band, valency band ಮೇಲೆ ನಾವು ಒಂದು theory explain ಮಾಡ್ತೀವಿ. So here what happens in the conduction band, whatever the electrons are there, that will jump to the valence band, that will jump to the valence band. So when it will jump to the valence band, it increases the conductivity. So for semiconductors, it will increase the conductivity when you increase the temperature. So therefore option B is the right answer. And metals ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ with increase in temperature, the resistance increases. The resistance increases. As the resistance increases, obviously the conductivity decreases. Sorry. So option B correct ಆಗಿದೆ. Yes, JNV. Option B is right. Hope so the concept is clear. Sorry. Is it clear, everyone? So we need to understand by conductivity concept of semiconductors here. Yes, is it okay now? So question number 18, option B is the right answer. So semiconductors conductivity increases and for metals it is decreases. Okay. So next question 19 we are solving. 10 identical cells of potential E and the internal resistance R are connected in series to form a closed circuit. Voltmeter reading we need to understand. See how to do this. Okay. So here we can take it as, that is the number of cells, they have given it as how much? That is 10. Okay. So therefore, n is equal to is equal to 10, and the potential of each is E. What they are asking, internals are connected in series. So now for the 3 cells, it becomes, see, n2 is equal to, it is 3, and n1 is equal to, it is 10. So therefore, n1 is equal to 10, n2 is equal to 3, potential is E, and the resistance is R. Okay, so from the Ohm's law, what we can write here is voltage across the 10 cell is given by. So the total voltage across the 10 cell is given by 10 into E. This is what? This is the voltage across the 10 that is the 10 cells. Okay. Similarly, the resistance will be 10 into R. This is the resistance, total resistance, and the total voltage. Therefore, the current is equal to, it is V by R. So therefore, it becomes 10E divided by 10R. So therefore, it is E divided by R. It is E divided by R. So they are asking across the 3 cells. They are asking for the 3 cells. Therefore, the potential across 3 cell is given by V is equal to I into R. Okay. So I value is, just now we have calculated, it is E divided by R into, for 3 cells, the resistance becomes 3R. So therefore, R will get cancelled. 3E, option B is the answer. C. 3E, option B is the answer. Yes, any doubt is there in this question? 19th is option B. Yes, right. 18th is option B. 18 and 19, both are B. Yes. Is it clear, everyone? Yes, is it clear? Any doubt is there?
No, ma'am.
Okay. Okay, students. So we will meet in the next class with few more questions on the current electricity. Thank you.